I hope you'll go along with this rather unusual setting and the fact that I remain seated when I get introduced, and the fact that I'm going to come to you mostly through this medium here for the rest of the show. And I should tell you that I'm backed up by quite a staff of people between here and Menlo Park, where Stanford Research is located, some 30 miles south of here. And if every one of us does our job well, it'll all go very interesting, I think. The research program that I'm going to describe to you is quickly characterizable by saying, if in your office you as an intellectual worker were supplied with a computer display backed up by a computer that was alive for you all day and was instantly responsive, instantly responsive to every action you had, how much value could you derive from that? Well, this basically characterizes what we've been pursuing for many years in what we call the Augmented Human Intellect Research Center at Stanford Research Institute. Now, the whole session is going to be devoted to trying to describe and present to you the nature of this program, but unfortunately, or fortunately, the products of this program, the technology of it, lends itself well to an interesting way to portray it for you. So we're going to try our best to show you rather than tell you about this program. A very essential part of what we have developed technologically is what does come through this display to us. And I'm going to start out without telling you very much about the program and just run through a little bit of the action that this provides us. So in my office, I have a console like this, and there are 12 others that are computer supplies, and we try nowadays to do our daily work on here. So this characterizes the way I could sit here and look at a completely blank piece of paper. That's the way I start many projects. So with my system, that's a good start. I'll sit here and say, I'd like to load that in. So, very sorry about that. So I'm putting in an entity called a statement, and that's full of other entities called words. And if I make some mistakes, I can back up a little bit. So I have a statement with some entities' words, and I can do some operations on these. I can copy a word. I can say that word like copy after itself. In fact, that pair of words I'd like to copy after itself, and I can just do this a few times and get a bit of material there. And there are other entities like text. Say after there, I'd like to copy from that entity point to that point, and it'll copy it. Great. So I could get myself some material on my blank piece of paper, and then I'd say, well, this is going to be more important than it looks, so I'd like to set up a file. So I tell the machine, all right, output to a file. And it says, well, I need a name. I'll give it a name. I'll say it's sample file. And I'll say, please output it. It says it did. And then it comes back automatically with an origin statement or header telling me the name of the file and the date and the time and who established it. And thereafter I can always do something. I can ask for the status of a file, and it'll tell me that information. Very small file now, owned by me, last written by me very shortly ago, etc., and other interesting data in there. So we've seen how we can start with a blank piece of paper and go to developing a file. This file is one statement with a few words in it. Let's make more statements. I'll say copy that statement, and lo and behold, I have another one. Copy that one, another one. I can even copy groups of statements. I can say after that one, copy the group from there to there. And it does. I can look at that and say, probably goes off the screen. It'd be interesting if I could ask the computer to collapse that, perhaps to show me just the first line of each of those statements. All right, please do that. So it did. This is one aspect of what we'll use over and over again through this presentation, what we call view control, where no matter where in a file we're looking, we can ask it to use any one of a large number of parameters for constructing a view at that point in the file that best suits our need at the time. This one wants us to give an overview of the thing. So I'll say, well, I have this. I don't want them all to be statement 1, so I'll just replace the word there with a 2. And how about that one with a 3? It's just a place to forget how to count. So I can look and say, all right, got statements 1, 2, 3, and 4. If I'd like to make them a little prettier, I can, I can go to work and neaten them up a little, but that isn't what I always do. Oops. You can tell that I have not warmed up yet. I hope you can tell. Right, all right. So I can get it lined up, and I can say, for instance, other entities like an invisible string. And I don't know whether that's tabs or characters in there, but I can say if I want to replace that invisible string with just one character, not that character, that one, space, and it'll do it. So I can look at that and say I have files 1, 2, 3, 4, 5, 6, and I've named them that way. But that's usually a sort of a pain to do that, so I'll ask it to number them themselves. And one of the views is such that it will give you a list numbering for each of those statements. And I can also open them all up or ask them without numbers, however I wish, and then I can output them. So we've seen ways to work fairly fast with the entities of a statement in a file, create a file. I can delete that file or mess it up considerably. Like if I'm going to say I want to delete that word, but I accidentally hit that entity instead, watch what happens. Sort of replaces the whole thing with nothing. That occasionally happens, so you say, all right, I'll load that file. And it'll come back in as it was. I last saved it, telling me the date that I wrote it. And unfortunately, I didn't save enough. Well, I'm through with this example right now. Let me go to a file that I prepared just after my wife called me and said, on the way home, would you do a little shopping for me? So as soon as she said that, I got my system organized. And made a shopping list. So it's got quite a few items on it, and if I want to, I can see that, yes, those are numbered statements. And I can say there are ways I can scan down it, like I can point to 10 and say put it at the top, and I scan up and point to 23, and I got quite a few. And I remember that's about as far as it got when she said, well, call me back when you're ready to go shopping and I'll tell you the rest of the things. So let me jump back to the head of the list, and I can do things like begin to reorganize it a little bit. Well, I say after bananas, it's more likely that I'll take the carrots there, and so carrots moved right up behind bananas, and aspirin doesn't really belong there. I think aspirin goes after paper towels in the order. Well, pretty soon I would begin to have a lot of trouble keeping that straight. So let me organize it by saying just generally produce. What the hell happened? All right, I'm going to try it again. I enter a statement that says, hey, that's what I do. Try there. I suspect that something's going wrong, and I would call up the programmer or the hardware man and tell him, I made it. Produce. I really haven't warmed up to this thing yet. So I'll say, well, produce, I'll categorize things. Let me look at it that way, and I'll say, let me move a statement for produce carrots, and I'd like to subcategorizing it. So it moved. And there it is. I go, hey, that's what happened. All right, produce, I've got carrots, and I'll move under there also bananas. And in fact, I could move a whole group under there, saying oranges and apples also. So I can begin categorizing things like that, and if I looked at the numbers now, I'd find that these items fit under there as a subset, and I realize I can categorize quite extensively. I could introduce a new thing under there that was something I just invented, a skinless banana, but I have to go there and look at it. So part of our view control, besides this thing we've shown you of showing numbers or not, is also whether we can show you some of these different levels or not. I can say I only want to see 2 levels. or only one level deep in there. It makes it very nice for studying it. Or I can do something like when I say, let's put produce at the top, let's open up one level below it and only show me what's below it. And then another level if I wish, and then no numbers. So these moving around with jump to identities, there are many ways to move around and to make views, and this is one of the basic features of this tool we have. Well, suppose I worked for some time at this and then call up my wife to get the rest of the list. I'd eventually end up with a whole structure where I could say, gee, there were a lot of things. A market, shoe store I have to stop to. Let me see what I was supposed to get in the market. Oh, produce, cans, cereals. What about cereals? Oh, cereals, bread, noodles, like that. Okay. Back up there, if I want to look at the numbers, that's what I can. If I want to open up everything, see that, or many lines. There are many ways in which I can look at that. And but one interesting thing here that I haven't told you about is that when the numbers are on, I can do something like, say, instead of jump to identity and pointing to that and having it bring to the top, or jumping return back, I can say a jump to a name and say go to 2A4. And it'll do it. Or return. So I can jump to a location number just by giving it, or if I wish, I can add it as text in there and say jump to name and just point to that and it'll go to 2A. Did I say that? Carrots, right? Right, carrots, 2A4. So I gave it the name of that, can go to it. I can give it the names of, I don't want to go that word, that one. I could say go to 1, which is out of sight from here now, and say jump to that, and at 1, different views. So it's very easy to jump around and make cross-references. It turns out if I wish, I can also make a cross-reference to something where I gave it a label or a name, such as you do when you're programming. I can call this alpha. Aha. I can say jump to name, and I can type it. I think I made a mistake when I type it. So what I should really do is say I'd like to reconform my whole picture. So there. It's going to say jump to name. And I jump to something named alpha there. All right, so I can give names, and I can say in here, a reference like that, where I can say jump to name, and point to that, and lo and behold, I'll go to this thing that I'd named alpha. So I can name it, and if I want to, I can ask to see the name, or I can ask not to see the names, depending on which. Right now we happen not to be seeing the names. So look what else we can do in here. I've got this file that's structured. If I want to see what's in there, I can walk down the hierarchy levels and see, or return. But there's another thing I can do. There's a root I said I have here. So here, I'm afraid I'll need a different picture of the view. So here's what I drew with a picture drawing capability here. It's a slight map if I start from work, and here's the route I seem to have to go to pick up all the materials. And that's my plan for getting home tonight. But if I want to, I can say, the library, what am I supposed to pick up there? I can just point to that, and oh, I see, overdue books and all. Well, there was a statement there with that name on it. Go back. What am I supposed to pick up at the drugstore? I see, very interesting. All right. Market? Oh, I've already seen that. Produce and all like that. Gee, that's too much. Anyway, so we have this feature of structuring our material hierarchically, being able to move around it very well. when we get a hierarchy, such as I can show you here now, I can do things if I want to just say, I'd like to interchange produce and canned materials. Bingo. And they're all numbered rightly if I care to look. Interchanging them very quickly. Cans are going to get interchanged with produce. They do it and all gets renumbered. So I have ways of studying over, making different views, moving around, going to specified points, and modifying the structure. At the same time, I've seen that I have a repertoire of different entities, like character, knock off that character, replace the character, make that P. So I have entities of all sorts that I can say I want to do operations on, and this basic structure that I can move over and study and get about very quickly. So that is the essence now. That's the essence of the tool we have. There are a lot of details that I've left out for you. And now I'd like to stop a minute and just make sure you understand we're shifting from illustrative material to the real working stuff, in case you wouldn't recognize it otherwise. We've used this tool to do our daily work, and our system has been built, this time-sharing system, for about 6 months now. It's been working. And in that time, we've gone from getting one console to getting about 6 working now, with 6 more due the rest of spring. This is our 4th computer in which we've had this kind of a system, so we've learned a lot about the user features we want and how to be fairly skillful. But this next step about learning how, when you're faced with having this in your office all day, as I now do, in a very exciting sense, how do you put that to work for yourself? How do you organize your files? What kind of things do you do? So to get going on this, let's switch away from the tool we have here and talk about some of the general features of the program, some of the ways it's built, and get back a little later to the nature of our usage of it. All right, let me get back to this material. Here's just the outline I'm going to use. You can realize that it's a file. These are statements, and we're probably looking at the top level of them. And the first one, the introduction, you can consider we've done. And the next one, overall about program, is what I'm going to do now. Well, I'm going to do something called jump on a link. And a link is something that'll go between files. So what it's going to do, it says I'm going to go to your file name as CNRO. And the link also says where in that file and just what view it wants. So when I do like that, I'm in the middle of that other file looking at this particular material that's been carved out by the specifications on that link. And this is telling me to make a preparation to start out on a presentation. But I should also remember I'm going back to this other file because what I want to do is restore a different kind of look. All right. Oops. I had to go to a different file in which, because I made a hitch in my rehearsing for this thing, in which I have many types of format structures set up and numbered, and I just reset the kind that I want to use to show you this material. We're very flexible with it. For instance, I can say I'd like to restore number 7 is a horrible example. See, I can have many ways in which I can control all of the parameters, character size, spacing, location, and everything else, but I don't usually go to this extreme, but it's just showing you that I can. The one I want right now is the one that shows you a simple large view. We usually work with a view, wait a minute. We usually work with something like this, where when we're working with our close spaces, we can do quite well, but it's felt that that would be a little hard for people to see, so we're using it like this, where we don't see as much material, but they're larger and clearer. So now let me go back to that file I came here from, and say, all right, now I'm ready. I'd like to jump and learn about the program. When I get in here now, it looks different, as it should. This is another file, and in this file I prepared a chain of views. And using some of the tools, I have it all set so I can go from one scene to the other. I could study them in the fashion I've shown you before, but it's sort of fun to set up these chains, and it represents to you a way in which we work too. So to do it, I'm going to freeze a statement that's named A, and I'm going to put on a certain parameter when I do it. And then I'm going to jump to a link. And here's a link. It says you want to go to statement A, but after the colon, all this garbage tells a bunch of abbreviated ways in which you'd like to control the view when you get there. Many parameters, as you'll notice. So I'll just say, all right, go to that one, and I'm looking at statement A. Now it's telling me this presentation is devoted to the HIRC. The natural question is, what's that? Aha. That was another boo-boo I made. I left several statements frozen. This statement I've asked to be frozen. That was the setup operation. It's just going to stay there above that dotted line as the viewing part of my screen from there down jumps around on the links I have set up. Okay, the first jump took me to this statement saying, all right, Augmented Human Intellect Research Center is what HIRC stands for. A hidden link will take me to the next one, telling you where it's located, that in SRI, it's an explicit organizational entity at what we call a group level. But also I'd like to point out there are other man-computer work going on at SRI, and ours is but one. So if I jump on a link, incidentally, I should just stop and reveal to you that the link is hidden under there. I was very clever to set the viewing parameters so they wouldn't show the link. But when I say jump to link and mark it there, the computer goes looking from there on for that link and obeys it. And I'm not showing the statement names either, but this is statement named B, obviously. So that program involves about 17 people together with the special laboratory facilities we have. It's sponsored by government agencies exclusively, ARPA, NASA, and RADC now, and in the past, AFOSR and ESD, and these were the people that first grub-staked us many years ago. All right. And it's been a goal-oriented pursuit for many years, and I think we can just go off and get a quick little picture I sketched to show this is the staffing over the years from 1950 on, and it's had slightly bumpy history. During these years, there was only one of us. I go back to where I was and say, let's continue on in this file. That link took me out to a different file, to a statement for that view, and I jump back to this file where I was, and now within this file I make a link to another to say, the HIRC is pursuing these goals. Basic goal, improve the effectiveness with which individuals and organizations work at intellectual tasks. What does their effectiveness involve then? Better solutions, faster solutions, solutions to more complex problems, with better use of human capabilities. Really thinking about that. But a corollary goal is, besides improving the effectiveness, to develop a system-oriented discipline for designing the means by which greater effectiveness is achieved. That's very important to us. The approach for this should result in the system-oriented discipline. Let me just show you how I constructed this file. You notice underneath there with that and that, there was just a link hidden here that went back to this view with a slightly different view parameters. To give you that view. All right, there's another one hidden there. It says the general approach for us, empirical. We're pursuing this monstrous goal, monstrously difficult, by building and trying empirically. And we're approaching it evolutionary-wise because we feel that it's a whole system problem. You need to get a person in that environment working and looking at the many aspects of his working system that are involved in his effectiveness. That's many more things than just these computer-aided tools. In a large system like that, we need to do it evolutionary-wise because we can't be analytic enough about it at any one point to decide what best our next thing should be. We can only decide from here, as well as we can analyze it, where we can invest our next resources to get the most return at an increase of the effectiveness of the system we have. And this item down here is the term bootstrapping applied in a slightly new sense. We're applying that to our approach, where we're saying we need a research subject group to give them these tools, put them to work with them, study them, and improve them. We'll do that by making ourselves be the subject group and studying ourselves and making the tools so that they improve our ability to develop and study these kinds of systems and to produce, in the end, this kind of system discipline. So it's a struggle doing it that way, but it's beginning to pay off. All right, from there. Sorry. I'm apologizing to my friend, the computer. I said jump to link and hit it up here, and it went and found these parentheses starting here and says that's not a link. I should have hit it here, and it'll find a real link, and I'm back in this list here, and I've given you an overall picture about the program, and that's out of the way, and I can just move my marker down and say let's save that version. So this tool, in pursuing those goals, one of our principal tools is this computer aid system. Let's talk about it as a system. There's a link sequence to jump in there too, where we talk about NLS, meaning the online system, a very general term. It's going to be NLS for many, many years, an online system that will evolve. Right now we consider it to be primarily an instrument and a vehicle for helping humans to operate within the domain of complex information structures. Well, what do we mean by operate? Well, compose, study, modify is the place we started now. We know there are many other analytic things you could do, but we want to get around, study, and modify. And then further information about what does complex structure mean. We're talking about complex structure and emphasizing structure because we say, although the content represents your concepts, there's a structural relationship between that content entities that should represent the relationship between the concepts of human thought. All right, we never can do that very well with linear text. So inside the computer we can represent that quite well. In fact, we can represent information structures in a computer that would generally be far too complex for you to study directly. But NLS serves as a tool to roam over that, navigate through a complex structure, be able to find your way and be navigating, move about it rapidly, and be able to see what you want to see at any given point. That's how we think of NLS as a tool. All right, these are all very important concepts to us because these, together with bootstrapping, have told us where to start. We start by building an instrument that we can sit at and work during our day to organize the kind of working information we need as a task force developing systems. We need to write our specifications, our plans, our programs, our users' guides, our documentation, our reports, and even our proposals. So we've been using these. Let me return back here and said I've finished that version, and to help you keep track of where we are, and in a little bit to help me too, we'll move that down. So having gone through these items, I'd like to come in now and begin to tell you something about the implementation. So I'm going to open up under here and talk to you about the control techniques, control devices, control dialogue, and control meta-language that we're using. Okay, to talk about control devices, we'll use this overhead camera shot where you can see the devices that I'm using. I use 3, and they're not all standard. We have a pointing device called our mouse, a standard keyboard, and a special key set we have here. And we're going to go for a picture down in our laboratory in Menlo Park and pipe it up that'll show you from another point of view more about how that mouse works. Come in, Menlo Park. Okay, there's Don Andrews' hand in Menlo Park. And in a second we'll see the screen that he's working and the way the tracking spot moves in conjunction with movements of that mouse. I don't know why we call it a mouse. Sometimes I apologize. It started that way, and we never did change it. All right. As it moves up or down or sideways, so does the tracking spot. And the principles for its operation are quite easy to see. If you'll turn it over, Don. Can you hear me, Don? Would you turn it over and we'll see? Right. Its principle is that there are two wheels that roll on the surface. But since they're at right angles and kind of sharp edges, one will roll and the other slide in one direction. Each of these wheels controls through a potentiometer with a voltage output sampled by an 880 converter the numbers taken in by the computer at sample times as to what the horizontal vertical components are to be of where it should put the tracking spot. And as the mouse moves over a surface, then each of those wheels either slides sideways without rolling or rolls an amount that very closely duplicates the particular component of horizontal or vertical in the net motion it makes. All right, if you take a mouse and move it through some closed trajectory back to exactly the same point, usually the tracking spot won't come back to exactly the same place it was on the screen. And for that sense, it wouldn't work well if you're trying to trace maps or other figures and diagrams. But the way we use it continuously and exclusively is to watch the screen and to follow it around, and we use this merely as a device to move that tracking spot. And your eye on the tracking spot, you really don't care whether it follows exactly this or not. In fact, we've had it at times where our tracking device, you had to move in an arc like that to make the tracking spot go on a horizontal line. And people adjusted to it and would go like that to go in a straight line and wouldn't even know that they were doing it. Other features of the mouse are that it stays put. I can lift it and replace it without having the spot change, so I can adjust where I want it for my comfort. And these control buttons on the top are used quite a bit, and I'll show you a little bit later how some of those are used. Now, the keyboard in the middle is essentially a standard typewriter keyboard, except for a few special keys out on the side. The computer knows it instantly when you hit one and makes an appropriate response. This device over here is unique to us, and we always have to justify and explain it. We'll do it in reverse order. We'll explain it first. It provides for you the one-hand equivalent of what you can do with a keyboard. There are 5 keys, and normally each finger sits on a key, and depressing any one key at a time produces a character. And any 2 keys at a time also. And in fact, any combination of depressing, of which there are 31 combinations. So Don